In this video we're going to be covering spheres, cylinders, and cones in geometry. We're going to be talking about surface area and volume. So the first thing you want to make sure you know is the definitions of surface area and volume and how we measure them. Surface area, there's two types. There's total surface area and lateral surface area. Total is exactly what it sounds like. It's the total or the sum of all areas of the faces or surfaces that enclose a solid or a 3D figure. Okay, lateral is the sum of the areas excluding the base or bases. Okay, so it's just the faces that are not considered bases. And both total and lateral are measured in square units, just like when you find area. So if it was centimeters, it'd be centimeters squared. Okay, volume is the measure of the amount of space contained in a solid, okay, or in a 3D figure. For instance, if you're going to fill a cup that's a cylinder up with water, okay, how much water would it take to fill that? That's the volume. Okay, cylinders that we're going to be working with in geometry are almost always going to be right cylinders, which means that this is a right angle created where the height, okay, goes down all the way down from base to base and makes a 90-degree angle. So in our example, this would be a 90-degree angle. Okay, you can, the formula doesn't change if it's not a right cylinder. You just have to be careful when you're identifying your height, because remember, base and height, or in this case the radius and the height, have to be perpendicular. Okay, so we have lateral surface area, okay, which is 2 pi r times h. Okay, if you recognize 2 pi r, which I hope you do, that should sound familiar, that's circumference of a circle. Because what that is telling us is this is a circle base. If we were to take this, like this was a label around a can, and we unrolled it flat, it's going to form a rectangle. Okay, now the height will be like the height of our rectangle, but when we unroll this, okay, that's going to be the base or the width of your rectangle. Okay, so it's the distance around the circle, which we call circumference. So this is circumference times height, because then it's base times height, because that label, when you unroll it, would be a rectangle. Hopefully that might help you remember that lateral surface area. And again, that would just be what's considered the label around the can. Okay, now total is going to include the bases, and in a cylinder our bases are the circles. We have the top circle and on the bottom, okay, this one's colored in so you can't see it, but here in the example you can see there's a circle on bottom and top. Okay, so we have our 2 pi rh, your lateral surface area, plus our two bases, and our bases are circles, so area of a circle is pi r squared. So two circles, those are the bases, and the lateral is the total. Okay, volume, okay, how much is it going to take to fill this cylinder, is pi r squared times h. That's the area of the base times the height. Okay, so let's look at this example over here and try it out. So we have a height of 7 and a radius of 4. Okay, so first I'll do lateral surface area. Okay, so my lateral surface area, or I guess I should say LA, lateral area, is going to be 2 pi, my r is 4, and my h is 7. Again, all of these that are dealing with circles, we can leave pi in the answer, so I'm just going to do the 2, 4, and 7 multiplied by each other and get 56. So exactly 56 pi, this is in inches, so inches squared. Okay, you can get that as a decimal if you'd like, and it's approximately 175.93 square inches. Okay, now for total surface area, okay, 2 pi rh plus 2 pi r squared. This has already been found. We found 2 pi rh right here. 2 pi rh is 56 pi. So I'm simply going to replace this with 56 pi. If you want to do all of that again, that's fine. Plug it in piece by piece, but I've already got a total for that, so I'm going to plug that total in. Lateral surface area. Now my two bases, 2 pi r squared. Okay, so 4 squared is 16. 16 times 2 is 32. So we have 56 pi plus 32 pi. Okay, when both terms have pi in them, you can treat that kind of like it's a variable, and so they're like terms, and so you could add those together and get 88 pi. And this is inches squared. And that's an exact answer. Now if you want a rounded answer, multiply that by pi. 88 times pi is approximately 276.46 square inches. Okay, so now we have our total surface area, our lateral surface area, and now let's find volume. So volume is pi r squared h. So pi 4 squared times the height of 7. So 4 squared we said is 16 times 7 is 112. So 112 pi inches cubed now, because we're talking volume. And we can get an approximate decimal answer by doing 112 times pi. And that gives us 351.86 inches cubed. So now you have all three of your answers. Alright, last but not least, we're going to discuss cones. Okay, cone has one circular base. It's kind of like a pyramid, but the base is a circle instead of a polygon. So here's lateral is pi r l. Total is pi r l, that's the lateral, plus the base, which is a circle, so pi r squared. Capital B is area of the base. Remember in area formulas, for instance, a rectangle, base times height is a little b. B is like a length of the base of a polygon. Okay? But in surface area formulas, you use a capital B to represent area of base. Okay, so that right there is area of base. And in this case, our base is a circle, so area of a circle is pi r squared. So you may see it written either of these ways. And then volume is 1/3 pi r squared h. You're going to need to know that lateral height, because most of you probably don't know what that L stands for. So here in the picture you can see the height makes the 90-degree angle with the radius, okay, or with your base shape. Okay, that's your height, vertically at a 90-degree angle with the base. Okay, your slant height, okay, is here exactly where you would think is slanted. Okay, it's the edge of the cone. Okay, it's not technically an edge because it's rounded, but it's what you would consider the edge when you look at it drawn out like this. Okay, so that's called the slant height. And if you notice, the height, slant height, and radius form a right triangle when you're dealing with a right cone. Because so if you're ever missing one of these pieces, you can go back to our right triangle rules, and you'll often use Pythagorean theorem. Or if you have your triples memorized, you'll use your triples. So looking in this example, we have 6 as a leg of our triangle and 10 as the hypotenuse of this triangle, because that's the slant height. So we have our L, we don't know H, and we know R. So if you remember your Pythagorean triples, there's the 3, 4, 5. Okay, 6 and 10 are both multiples of 3 and 5. Okay, so this could be a 3, 4, 5, but they've just been multiplied by 2. So that would make this 8 feet. So then it's the ratio 3, 4, 5. So now we have our missing piece. Now we can find lateral surface area, pi r times the slant height. So that would be 60 pi, and this is in feet, area is squared. Okay, if you want to get that as a decimal, 188.50 when you round to hundredths. Okay, now total surface area is going to be the lateral. Okay, that's what we just found. So 60 pi. Rather than solving this again, I'm going to use what I've already found, plus pi r squared. Pi r squared. 6 squared is 36, so we have 36 pi and 60 pi. So that gives us 96 pi square feet. Or as a decimal, 96 times pi is approximately 301.59 square feet. Okay, so we've got lateral and total surface area. Now we just need our volume. So volume is 1/3 pi r squared times the height. So this is why we needed to find that height, is for volume. So 6 squared is 36 times 8 is 288. So right here I've got 288. I only need 1/3 of that. So that's 96. So this is 96 pi. And this is feet cubed for volume. If you want that as a decimal, multiply 96 times pi and get 301.59. We got our volume. Okay, now don't think that that's going to happen often. Okay, that was just a coincidence. That is not going to happen often. Alright, last but not least, spheres. Okay, notice sphere, I only have one area formula, and it's total, because a sphere does not have a base, so you can't exclude that to get lateral. So simply total surface area and volume when we're dealing with spheres. Okay, hopefully by now you know that a radius goes from the center of a circle to the outer edge. Same thing for a sphere. This example gives a good depiction showing that it can go in any direction, okay, as long as it goes from the center to the outside edge. Okay, so in our example, our radius is 5. So we have our total surface area is going to be 4 pi r, which in our case is 5, squared. 5 squared is 25 times 4 is 100. So we have 100 pi. Remember, this is in terms of pi, and our measurements are centimeters squared. You can get an approximate answer by simply multiplying that out. And again, I would use the pi button, not 3.14, so you'll get a more accurate answer. You won't have rounded too soon. So this would be 314.16 when we're rounding to hundredths. So that's our total surface area. And then volume is 4/3 pi r cubed. So 4/3 pi, then our radius cubed. And remember, cubing is just the number times itself 3 times. So 5 times 5 times 5 is 125 times 4/3. You're going to get a repeating decimal. And so I would prefer you to leave it as a fraction. So 500 over 3, because the 125 times 4 is 500, and I've left it over 3, pi, centimeters cubed. And if you want to get an approximate answer, you can take that 500/3 times pi and get approximately 523.60 when you round to hundredths. And again, that's centimeters cubed. So here you've got volume and total surface area.